So in this video, we'll be discussing the lens of the eye. We'll start by defining some basic terminology, reviewing relevant anatomy, and then discussing the two main functions of the lens, and we'll conclude with a discussion of presbyopia. So you've probably already heard of the terms phakic, pseudophakic, and aphakic, so let's just review what these all mean. So phakos in Greek means lento, and that's actually how the lens got its name. So phakic means a natural lens, pseudophakic means artificial lens, and aphakic means no lens. Sometimes you'll see the abbreviation IOL, and that stands for intraocular lens. And this can be placed either in the anterior chamber or the posterior chamber after cataract surgery. And in the past, when cataract surgery was much more invasive, the entire lens was removed and an intraocular lens was placed in front of the iris in the anterior chamber. Nowadays, we typically use a much less invasive procedure called phacoemulsification, and this preserves the posterior capsule, allowing the IOL to rest snugly against it in the posterior chamber. Okay, so let's review the anatomy of the lens. So this diagram is actually quite involved, so if we just simplify, we can see that the lens actually consists really of three components. So there's the middle nucleus, there is the outer capsule, and then in between is the cortex. And you can think of the lens really like a peanut M&M. So the hard candy shell is the capsule, the nut in the middle is the nucleus, and the chocolate layer in between is the cortex. So if we review this diagram now, we see that the most superficial layer is the anterior capsule, followed by the lens epithelium underneath, which is very mitotically active. Underneath the epithelium is the anterior cortex, and then the nucleus, followed by the posterior cortex, and then finally the posterior capsule. So the lens is the densest tissue in the body. It has the highest protein percentage and the lowest water percentage. And amazingly, it is able to remain optically clear for decades. Most individuals do not develop cataracts until either middle or late adulthood. Now, one of the primary functions of the lens is to provide refractive power that focuses light onto the retina. So the lens accounts for about 1/3 of the total refractive power of the eye, or about 20 diopters. Actually, the tear-air interface on the cornea accounts for the other roughly 2/3 of the total refractive power of the eye, or about 40 diopters. Something that the lens does that the cornea doesn't, however, is accommodation, and this is facilitated by the lens's flexibility. Here's a diagram showing how the ciliary muscle, zonules, and lens all interact to allow for accommodation. So just to review, accommodation is the process by which the eye focuses to see near objects. So normally for distance vision, the ciliary muscle is relaxed. There is a lot of tension in the zonules, and that keeps the lens nice and flat, and we can see that here in diagram A. Now, when we shift our gaze to close objects, our ciliary muscle, which is a sphincter muscle, actually contracts. And this actually releases tension in the zonules, causing them to relax. And this allows the lens to become much more round, and this increases the refractive power of the lens and allows us to focus better on near objects. So unfortunately, as we age, our lens becomes more stiff and less flexible, and it cannot relax or round out to a sphere as well. So instead, the lens stays flat, and this prevents the proper focus for near objects. So this condition is called presbyopia, and this is similar to hyperopia or farsightedness in that light rays focus behind the retina. Fortunately, presbyopia is easily corrected with plus-powered lenses or convex lenses, and most people will eventually need bifocals as they age, with some as early as age 40.